Quantum computing and AI. Can they break encryption? Quantum computing and artificial intelligence. Two of the most powerful technologies humanity has ever created. But together, could they become the ultimate code breakers? Could they shatter the encryption that protects our banks, governments, and even your personal messages? Today we're diving deep into the future of cybersecurity to answer one question. Can quantum computing and AI really break encryption? Stick around until the end, because I'll also share what governments, tech companies, and even you can do to stay safe in a world where encryption may no longer be unbreakable. What is encryption? First, let's break down what encryption actually is. Every time you send a WhatsApp message, make a credit card payment, or log into your email, your data is being encrypted. Think of encryption as a digital lock and key system. The most common form today is RSA encryption. It works by taking two massive prime numbers and multiplying them together. The result is a gigantic number that's easy to multiply but almost impossible to reverse engineer. For a classical computer, factoring that number could take billions of years. That's why encryption is considered secure. And it's not just protecting your text messages, it's the backbone of online banking, e-commerce, cryptocurrencies, healthcare, and national defense. Without encryption, our digital society as we know it would collapse. Quantum computing. Now here's where things start to get interesting. Quantum computers don't play by the same rules as classical machines. Instead of simple zeros and ones, they use quantum bits, or qubits, which can exist in multiple states at once thanks to a property called superposition. Combine that with entanglement, and suddenly, quantum computers can perform calculations that would take a classical supercomputer thousands, or even millions, of years. One of the most famous breakthroughs is called Shor's algorithm. It's a quantum algorithm that can factor very large numbers exponentially faster than any classical computer. And remember, factoring large numbers is exactly what RSA encryption relies on. Researchers estimate that a quantum computer with around 4,000 stable qubits could completely crack RSA encryption. To put that into perspective, IBM, Google, and others are already building machines with hundreds of qubits. That means we may not be too far away from crossing into dangerous territory. How AI fits into this. So, where does artificial intelligence fit in? AI alone won't break encryption, but when paired with quantum computing, it becomes a force multiplier. Quantum computers are notoriously unstable. They produce lots of errors due to noise and decoherence. That's where AI comes in. It can optimize quantum error correction, help design better algorithms, and even guide quantum machines to find the most efficient pathways for solving problems. Imagine an AI acting like a GPS for a quantum computer. Instead of searching blindly, it directs the quantum system toward the fastest route to break encryption. That combination of brute force quantum power and AI-guided optimization could change the cybersecurity landscape forever. Real-world threats and case studies. And now let's talk about the real-world threats, because this isn't just theory anymore. Governments, banks, and big tech companies are actively preparing for a future where quantum computing could shatter today's encryption. The U.S. National Institute of Standards and Technology, NIST, has already launched a global competition to design post-quantum cryptography standards. Researchers worldwide have submitted algorithms that could resist quantum attacks, and these are now being tested to eventually replace RSA and ECC. And it's not just the US, China, Europe, and other nations are racing ahead. China has invested billions into quantum research, and in 2020 they launched the Michia satellite, which successfully demonstrated quantum key distribution, a method of securing communication using the laws of physics instead of math. That's a glimpse into how countries are already testing new defenses. Cybersecurity experts also warn about something called Harvest now, decrypt later. The idea is simple. Hackers, corporations, and even state actors may already be collecting encrypted data today. Banking transactions, government secrets, private communications, knowing they can't read it yet. But once powerful enough quantum computers exist, they could unlock all of it, potentially exposing decades of sensitive information overnight. There are also signs of early hybrid attacks. In 2022, researchers demonstrated that smaller quantum machines, when combined with AI optimization and classical computing, could already weaken certain types of cryptography. While not a total break, it shows that these tools don't have to be perfect to start disrupting security. Meanwhile, the private sector isn't waiting around. Banks like JP Morgan and HSBC are running quantum security pilots to protect their systems. Tech giants like Google and IBM are partnering with defense agencies to ensure their technology is ready for a post-quantum world. This isn't science fiction anymore. It's a global cybersecurity race, and whoever gets there first could gain an unprecedented advantage in finance, defense, and intelligence. Can encryption survive? So, does this mean all of our data will eventually be exposed? Not necessarily. New solutions are already in development. Scientists are building post-quantum algorithms, lattice-based cryptography, hash-based systems, and code-based encryption, designed to resist quantum attacks. AI itself could even help on the defensive side, monitoring for unusual activity, automatically adapting to new threats, and creating smarter security systems that evolve in real time. But make no mistake, this will be an arms race. Quantum plus AI trying to break encryption versus next-generation cryptography trying to stay one step ahead. Conclusion. So, to answer the big question, yes, in theory, quantum computing and AI could break today's encryption systems. But the cybersecurity world isn't asleep. It's already preparing for the day when that becomes possible. We are entering a new era, one where the future of security won't just depend on stronger passwords or firewalls, but on quantum machines, advanced AI, and cryptography we haven't even fully developed yet. Thanks for watching. If you found this video insightful, don't forget to like, subscribe, and hit the bell icon for more deep dives into AI, quantum computing, and the future of technology. And now, I want to hear from you. Do you think quantum computers will actually break encryption in our lifetime? Or will cryptography always stay one step ahead? Drop your thoughts in the comments below. I'll be reading and replying.